and welcome to episode 144 of The Joy of Coding. My name is Mike Conley. It's July 4th, 2018. Glad to have you here. Hello, how's it going? Let me just open up a can of my beverage here. How are you? Let's get started. What are we up to today? What's going on? Whoops. Let me try that again. There we go. Today is July 4th, 2018. So for the people who are celebrating the 4th of July in the United States, happy 4th of July. If you're watching this on the 4th of July, thank you for taking time out of your holiday to watch me sort of screw around on my computer. If you were from Canada, happy belated Canada Day, if that's what you were celebrating. Right, so a quick reminder, no plan survives breakfast. If there's been a recurring theme over the past 2 minutes is that things will invariably go a little bit wrong. I don't know if you noticed that, like some of my transitions have been a little bit off. I'm playing a little off the cuff. That's okay. This stream is me trying to capture what I do live. It's not supposed to be perfect. It's not pre-planned. Things might go wrong. I might not find all the solutions. That's all right. It's okay. So don't freak out. We're doing it together. So I'm just setting the tone there. Things might go wrong, and it's all right. And the second thing is that there's an episode guide. There is a viewer-driven episode guide to The Joy of Coding. If you're new to the series and want to get a sense of what I talk about in each of the episodes, because we're up to 144 now, we've got almost every episode. Some are not available. Some, were skipped, and the episode numbers still incremented. But we've got all the way up to the last episode, 143, and some of these episode guides have links to not only the agenda and like what I talk about. They might link to the bugs. They might have topics. The sorts of things that I did on the stream. Like on this one, a topic was added of the bug I was working on, and that I cracked the case. And maybe form autofill was the culprit. Turns out it wasn't the culprit. That sort of thing. That's what you get with the episode guide. And it's available to you and something that you can also contribute to. If there are things that you feel would be useful to add to the episode guide, all of this, every single line that we're looking at here in these episode guides was viewer contributed. So viewers just like you can make this thing happen. How you can do that is by sending a pull request to the repository, and these links that I'm hovering with my mouse are probably not very useful unless you know how to get to the agenda. So I'll tell you how to do that next. So this agenda that we're looking at, even though there's no plan, I do have some kind of agenda. This agenda is something that you have access to. If you're watching this on YouTube, check out the video description down below. The agenda's in there. If you're watching this on Twitch, well, I'm about to drop it in the Twitch chat. If you're watching this on the Legacy Air Mozilla, here you go, Twitch people, agenda. If you're watching this on the Legacy Air Mozilla somehow, then it'll be in the additional links section down below. And if you're watching this on the new Air Mozilla, it's in the handout section, which should be, I think, to the right side of this video, over here somewhere. So you can go check the links out and get an access to this episode guide, which updates as I edit it. So like if you see that little thing spin inside Evernote, then you can reload the agenda and you'll get the most up-to-date version. There are links in here on how you can send pull requests to the repository. There are links on how you can create transcriptions for the videos if you want to update the transcriptions. There's a long backlog of videos I need to do automatic transcription for. I haven't done them yet. But a bunch I already have. I think episodes 1 through, some of them need work. The ones that are marked in orange need work, but the ones that are marked in green, they're ready to go. And so if you want to add some transcriptions, you can create an amara.org account and then click these links and send me transcriptions that, for things that need done. Need done? Transcriptions. Send me transcriptions for things that need corrections. That's it. All right, so a quick check, is everything working? I'm using a new version of OBS. Is everything working? Thankfully, it's using less CPU than I'm used to. Normally, it uses about 20% of my CPU. Right now, it's only using 9, so that's great. Thanks, OBS. I'm using OBS version 221.1.1. And it's using about 9% CPU. That's great. Let's see here. And you can hear me, and we've got sound. Great. So, I already said that. Let's get into what we're doing today. So, I was put in touch with an intern who's working for Mozilla, who's interested in some intermittent orange work. This fellow's name is Moritz. I hope I'm pronouncing that correctly. Moritz. Moritz is interested in seeing what I go through in order to fix an intermittent orange. Also, there's a question in the Twitch chat. Hold on a second. I'm going to try and address this. Is stuff in web browsers, the HTML, the markup, and the CSS styles, painted to the screen, or does it use native controls that are appended to some kind of panel? So I can tell you about Firefox. We paint everything in this window ourselves. Even the things that look native, like these. Let's see, what the select dropdown might look kind of native, or the buttons. Like if you see like a form, let's see, MDN form button. So, form and button basics. Let's take a look. Basic form. Let's see an example. We get an example here. Form element. Hold on. I'm trying to pull up the example of a button. Like these buttons look native, but they're not. We are talking to the operating system to figure out how to draw them, and then we draw them ourselves. So hopefully that answers your question. MAGGGES. At least for Firefox, we painted everything in the content area. We paint ourselves, and a good chunk of what we paint in the Chrome area, that's the user interface area, is painted by ourselves. Even these, like the stoplight buttons on Mac OS, these we ask the operating system how to paint them, and then we paint them ourselves. And that gives us a very high level control of how we present to the user. It also means we have to do a lot of extra work sometimes. So hopefully that answers your question. So yeah, I was hoping to look at some intermittent orange stuff today. Let's get into it. So what's an intermittent orange or an intermittent failure? We have a bunch of automated tests that run, a whole slew of them, thousands and thousands of automated tests that exercise various functions of the browser. And the best case scenario, these tests run the same way every time, but sometimes non-determinism comes into play. The test might be testing something that may act in one way in certain cases and may act in other ways in certain cases, depending on how threads are prioritized, how timers are functioning, how hot was the room the machine was running in. Like there's a bunch of stuff that can affect the run of the test. Maybe how busy the machine was. Maybe an update was being applied in the background. Who knows? The screen resolution. All sorts of factors can affect these tests. And so sometimes these tests will fail intermittently. So they'll be green, they'll pass 90% of the time, then they'll fail 10% of the time. And we don't really like that. Usually what you want is to have your tests be reliable. When they fail, you pay attention to them because something's gone wrong. And you don't want to just say like, oh, well, that failed because it sometimes fails. You want to be able to rely on your tests. So there's this ongoing effort to reduce how many intermittent test failures we have. That's called our orange factor because test failures are generally coded orange in Mozilla infrastructure. And we have this tool called intermittent failures on Treeherder, the intermittent failures view, that shows us the list of like the most wanted list for intermittent failures. And so I was hoping maybe we could take a look at some of these today, or maybe just look at one of them today. And immediately I can tell that there are some that we probably don't want to touch. Like Stockwell Infra is more about infrastructure. It's about the machines that are running the tests and less about the tests themselves. So we can ignore that. This is also similar. Tool is part of our infrastructure, so I'm going to ignore that. I'm just going to pick one at random here. This one's fixed by a backout, Talos regression. Oh, you know what? I wonder if I already have one in my backlog that I want to look at. Let me quickly open up, pardon that noise, let me quickly open up my dashboard to check. Magus, Maggges, asks, on the earlier stream or on an earlier stream, I saw that you use code reviews. Do you use some kind of static analysis like linters or even SonarQube to analyze the code? Yes. We have a number of linting tools. We do address sanitizer builds. We do thread sanitizer builds. We run like Clang format to clean up some of our formatting. We have various Mozilla plugins. We run ESLint on a bunch of our JavaScript. We run PEP8 and PyFlakes on our Python. And we do Valgrind runs to check for memory leaks. And there are more. But yes, we have plenty of static analysis tools. All right. So I think I have I have an intermittent failure we could look at here. Let me just make sure that this is frequent. Okay, yes. Let's look at this. Again, I'm gonna turn that add-on off. That add-on makes a noise whenever certain things occur. I'm gonna turn that add-on off for now because it's making noises. Disable. Okay. So in this automated automation test intermittent failure, a test it's a Talos test failure, actually. And what's happening is a test is running out intermittently. It's almost a permafail. And because we permafailed mostly on Mac OS, we have ended up disabling profiling and just general TPS runs. That's the test that was failing. TPS, we disabled it on Mac OS in our automation. And not great. And if I remember correctly, I had looked at some of the intermittent failures here. And let's see. I think I had a log that I was looking at. 24th. That was on Windows 10. Did it fail on Mac on Windows 10 in the way I? Hard to say. No, this looks more like it was attempting to use tool, and it failed. It timed out. So that's not exactly right. I'm going to change the date range. Let's look at the entire history. Let's look at here in 2018. And we want to look at maybe Mac OS. If I remember correctly, we were starting TPS, and what happened? So just so people are aware of what I'm doing, I'm looking at the logs trying to find information about what went wrong. And the reason I'm doing that is because this might be, no, that's not the one I want. I want Mac OS non-profiling. Is that even out there? These are all profiling. I want non-profiling. Was it only profiling builds that were failing? So here's an example of the failure. Test timed out. And then failure start here. And then it was broken up into two different issues. Right. So it looks like Julian Descott, or Julian, found the relevant lines here, and there's an assertion failure when we ran the unload timer here. So this was in a debug build, I think. Failure log from here. So this was macOS nightly profiling. Let's look at the raw log. And then the artifact's expired, so we can't look at it. Shoot. So yeah, let's see if we can figure out what's going on here. The assertion failure is what's, I think, the problem, and the assertion is at the async tab switcher line 447. Let's open up the async tab switcher. And unfortunately, the code's a little bit out of date. We're gonna have to maybe take a look at that particular, if we wanna look at the exact line numbers, we should look at the code in here for that particular push. So we'll examine the files in that push. I think I've done this before. A lot of these links are colored. Yeah, I had clicked this before. I've done this before. Maybe I should start taking some notes soon. But at any rate, assertion failure 447, and then calling that. 447 is, I think, where we throw the error if we've asserted fail. Yeah. So there, and then 300 is where the actual assertion is taking place, right here. So asserting that there's no blank tab at the time of finishing. Very interesting. So a blank tab is existing when it shouldn't. The blank tab. Okay. Good to know. Let's see what else we can derive from this. Well, for one thing, these assertion failures shouldn't necessarily, I mean, they'll print. Assert debug, assertion failure. See, they only like throw an exception if we're in debug mode. Otherwise, it just prints out to the disk, or prints out to the console. And I think that's what happened here. This wasn't a debug build. And apparently the timeouts are linked to this patch that I wrote. Where I'm using Moz layer tree ready in the parent process. All right, let's start taking some notes. So the problem appears to be that at shutdown time for an async tab switch, we assert that there's no blank tab, and yet there is one. The patches that caused this regression to appear on Mac OS are a change in how TPS works. So this is actually probably a problem with the test and not Firefox itself. And let's see here. The patch that caused this, and then I might as well just link to it. this bug, apparently. Switches the TPS test from using Moz after paint to using Moz layer tree ready to determine if and when the tab switch is complete. So what could be happening here? The unload timer runs. So we've got presumably all of the we've finished showing the new browser, and then we're clearing out all of the old ones that are to be unloaded. We realize that we're all done, and then there's still a blank tab somehow. How could that be? We update the display here in post actions. So post actions should have been called. And update display checks to see if there is a blank tab, and if there shouldn't be a blank tab, and if there isn't, we should null it out. So we must either decide that we should be blank. And so the window is either minimized, not minimized, should be blank is only true if has sufficiently loaded. So what if the tab that we're switching to has not sufficiently loaded? That doesn't make much sense. Or there's no tab parent. What if the content process crashed? Or minimized or fully occluded? If not minimized or fully occluded. So if this is false and we're not minimized or fully occluded, and we either have no tab parent, or we've decided we have not sufficiently loaded and never presented. Interesting. So I guess one thing we could do is see if we can still we still get some of these failures on Central and Windows 10. It's very interesting. I wonder if they get the same assertion failures. No, I don't see an assertion failure there. And I wrote, we're failing an assertion that would definitely cause test time. We should try to figure out why the assertion is failing. Okay. So here's what I think we should do. let's see if let's update to 498.715, and we're going to turn this back on. Talos TPS and test sets. Times out 3007 times out. So I've turned it on for test sets, and let's see if we can get it to fail. Re-enable TPS. What's more, I will enable some logging. I use dump for logging. True. Enable tab switch logging. And then I think I can push this to try and do an artifact build. TPS. Mock. Try fuzzy.
Mamma mia!
Come on, what's going on here? Mock try fuzzy. Well, while we're waiting for that to get itself together, what ultimately I'm going to try and get this thing to do is fail in automation with logging enabled, and hopefully that gives us more information about what's going wrong. Maybe it'll just tell us, oh, you need to add even more logging to know what's happening. But that, I think, is going to be the strategy here. Try to use logging to determine what's going wrong. And I'm not sure what the dealio here is. TPS E10S. Maybe I should just ask for that. So HT push to try. I'll say Mac OS artifact build opt only, and then Talos. I'm going to say repeat. I'm going to make it repeat 10 times, but I'm going to replace a bunch of this stuff. So repeat 20 times. Try and get that failure in there, and then it's TPS E10S. And then I'm going to say Mac OS TPS with logging. And let's see what happens. And I restarted my computer recently, so I need to add my SSH key. All right. Shout out to Dark Spirit, who in the hash live hacking channel went to the joy of coding in the chat. Really appreciate it. And I'm not entirely certain if Moritz is in this chat, but Mech might be Moritz. Let me just check here. Hard to say. Hard to say. But Moritz, if you're watching, do let me know. Hello, Tomato Shadow. Good to see you. Just trying to push this thing to try. And in the meantime, let's see if we can identify a different intermittent that we can start looking at. I think I actually had another one that I wanted to look at. Let me open my dashboard again outside. There was another one. What was it? Okay. Here's another intermittent failure. Tomato Shadow says, appreciate the stream. Hey, I appreciate you, Tomato Shadow. Okay, so in this intermittent failure, this was on Linux 64 JSDCov. So I think that's code coverage, JavaScript code coverage. And here's the relevant snippet for the from the log. Test unexpected fail. In about session store, the browser is focused. And I was need info. Since you worked on this test in the past, maybe someone in your team can look at it. And then Joel Marr says, keep in mind that this is only failing with collect JS coverage via the DevTools debugger. I expect that it's okay to disable for that config. And then it was disabled 3 months ago. And so what's failing is this test. Browser bug 495058. Let's take a look at it. Did our push go through? Yes, it did. So we'll wait for that to cook. So what this does, it tests that the right elements of it, let's pump this up a little. Tests that the right elements of a tab are focused when it is torn out into its own window. And so what the test does is it creates this set of URIs about blank and about session store and about private browsing, and then it goes through each one, adds a new tab for that URI, loads the URI and waits for that to occur, and then we tear it out. And we wait for content. We wait for the content to first paint before we focus the URL in the new window to optimize for content paint time. That's true, we do that. Focus the URL in the new window to optimize for content paint time, and then we wait for browser delayed startup finished. And we like wait for both of these. And then we make sure that the right things are set, like the URI is set, the active element is focused. Like the active element is the browser, but the value of the URI is empty, I guess, because there are these URLs. And then the placeholder text is present. Okay, then we close the window. And what's happening in the log is, when do we start? About blank browser is focused. So the active element was we expected it to be focused. We expected it to be the selected browser, but it wasn't. Okay. And what did this fail? What platforms did this fail on? Linux. Linux 64. Okay. So what we can do is we can try to sign into beast mode, my Linux VM. directory, hopefully. And then what I'm thinking we might try and do is try and run this test with mock test verify. I can revert this change, don't need that. So we're going to run mock test. We're going to run this test. We're going to run it with verify. Whoops. B browser. And set the display to display 0. I'll run it with verify and see what happens. Because if you can reproduce the test failure, that is a lot simpler to work with. That's one lesson for you people out there hoping to work on intermittent test failures, is the key to fixing an intermittent test failure is understanding why it's failing. And the easiest way to understand why a test is failing is by reproducing it locally and either using logging or a debugger to try and figure out what's going on. And unfortunately, some of these tests only fail in automation, and that's very frustrating. But if you can get it to fail locally, usually you can close the loop. You can get a lot more information more quickly because the feedback loop is tighter. You can work with your own machine as opposed to pushing to try and hoping a couple hours later that you get some useful information. So right now, test verify is running. So far, we haven't gotten any hits. I haven't gotten this thing to fail. And the other thing to keep in mind is that it fails when running the coverage, the code coverage part. So when the machine is, I would imagine, more encumbered, it's talking to the JavaScript engine, trying to get like JavaScript execution information out of the JavaScript engine. So we might try that variation on the test in a second. I'm not even certain how to run that, but we'll find out shortly. So one of the things it's also doing is it's running in chaos mode. Chaos mode allows us to modify thread priority, just basically muck around with things that tend to cause intermittent test failure, like thread prioritization or order inside of unordered sets, that sort of thing. It'll like intentionally fiddle around with the ordering of things that are supposed to be out of order or not ordered, and it will randomly reassign thread priority. And that can sometimes help help draw out intermittent test failures. I don't have high hopes though. This all looks like it's running pretty well. So is there any information about how to run JS decov? Apparently I can just run jscov prefects. Okay. Right, so test verify did not produce any useful information. But what I will do now is I'll create a cov directory under projects. It's empty, and I'm going to say jscov dir prefix, and then say projects cov. Let's see what happens now. Will it actually write anything? It did. It wrote some stuff. Wow. Look at all this information. So now I'm going to do that again, but with verify. And if that doesn't work, if that doesn't draw it out, then I'm going to run the whole directory. Because notice that, like, this test failure, if we look at the log, where is the log? This test failure is, this is a snippet from a whole series of tests being run in order. Usually we run each directory in its own profile, and so maybe one test is affecting another. A previously running test, for example. So what's going on in, we're creating all these like coverage reports. This is crazy. Artifact builds tend to not take too long, so let's see how our artifact build is going. Oh, it built it. That's great. Now we're just waiting for the Talos machines to free up to run our tests. That's good. So now it's running the JS coverage tests with verify with the chaos mode. I'm not seeing much going on there. So this might be another case of trying to get it to, like, the worst case scenario, and the thing that takes forever is whenever you can only reproduce it in automation, and so what you do is you end up pushing to try multiple times with more and more logging and looking at the logs to try and see what's happening. And that's the worst case scenario, but unfortunately it often comes to that. Because it takes a long time to figure stuff out that way. So we focus the browser, actually, if I remember correctly, here inside set initial focus. Set initial focus is called by on DOM content loaded. And the way it works is we'll wait until first paint. We'll also wait for first non-blank paint. Call with URI to load if it's a blank page. And we focus and select the URL bar if it's a blank page. This should be a blank page. Right? Like if I have an about blank, I move this to a new window. All right. URI to load. If the initial browser is not remote, we can focus the browser immediately with no paint performance impact. Otherwise, focus didn't move while we were waiting for first paint. We're okay to move to the browser. So that could be what occurred. A focus moved. So this is where I'm probably going to add some logging, is in here. Okay, so they skipped the coverage stuff. Skip if coverage. JSDCov, okay. But that was R minus. And this one is R plus. Why did they end up going disabling on coverage? 896, 89588. Still failing on the next key. Let's take a look. It's coverage, not JSD cub. We still have a chance to change JSD cub flag from coverage to JSD cub. Okay, so I need to modify this file and then we're going to change the skip here. Comment that out. Where are we? I guess I should go back to here. HG shelve and then update to here. And then unshelve, and then let's add our logging, and our logging will say like dump testing URI. Tearing out tab now. Waiting for browser delayed startup finished in new window. Waiting for content to be painted in new window. Oh man, there we go. Checking running assertions. Okay, so there's my logging there, and then over here, set initial focus called. Dump initially focused element has class, has tag name, ID. Oh, this is gonna be a really long and classes. It's a long log message, and then getting the deferred there. Saw browser first paint. Removing blank attribute. And then call with URI to load. What is that? If URI calls the given callback with the URI to load at startup, synchronicity possible or after URI to load promise. So we check to see if there's a URI to load promise, and if there isn't, then we call the callback immediately with the URI to load. Otherwise, we wait for URI to load and then call the callback. Okay. URI to load promise resolved. URI to load is URI to load. Focusing and selecting the URL bar. Selected browser is remote. Waiting for first paint. Saw first paint in remote browser. Focused element has changed, not focusing browser. Focusing browser. Current, let's see here, let L equals document.command dispatcher.focused element. Dump focused element is L.tagname. All right. Else, if the initial browser is not remote, so focus it. Okay. I think that'll work. Mock build faster. Let's see how our try push is doing. Still queued up. These tests have not started yet. Queued for about 20 minutes. Boo. Meg asks, hey, Mike, what level of authentication or authorization you need to be able to run a test on automation like you did just before the artifact build? Can anyone do that? You need to have L1 commit access, Mozilla level 1. And it's reasonably straightforward to get level 1 access. That gives you access to try and a couple of other repositories that most people don't need. But this is the lowest level of access, and yeah, a bunch of people have L1 access who are like not staff. Like you can just, as an intern, I think you should definitely get access to level 1. And to do that, let me just paste this link here in IRC. And I'll also put a link to that in the agenda. L1 commit access. And I think there's also like a procedure. The procedure. And so I can add that. Okay, so we're done. We're done with that modification. Now let's run this test locally. Mock Loki test, just to make sure that we haven't broken anything. Browser bug 495058. Rid-do-do-do-do. Rid-do-do-do-do. Hope we didn't break stuff. Ooh, broke something. Whoa. What, how did I break things? Did my logging break things? Oh, initially focused element is null on line 1590. So if initially, that's why you always test. there's an initially focused element, else dump, there is no initially focused element. Great. Okay, that's what we wanted. So we're gonna push that to try. Re-enable JS coverage and log a bunch in the test. And now how do we run this? Yeah. That's what we're gonna do. And who knows how long that'll take? That might take a while, but we'll see. Are there other intermittent orangey things that we could work on while we're waiting? Oh, we got some tests running now. That's nice. That'll take a couple minutes. So before the episode's done, we might have some information there. Let's look at more. This one is a search one. Intermittent. Browser components, places, test, browser. Browser bookmark properties, new folder. Test timed out. That started with this push, which is a places test, or a places patch that fix updating the folder name in the bookmarks properties menu list when it changes. So, you know, fix some behavior and then all of a sudden regression. And Mark Banner's like, I'm a bit at a loss here. The test is attempting to edit an item within the folder tree in the star UI. It sets the key for the title and then VK return except the key. In the broken cases, the folder tree receives only the VK return. It doesn't receive a change of the value in the field. Hence, when it processes return, there's no change, so we never get notification of on item change. The test time's out. Seems to be happening on debug builds, hence probably timing. The pop-up definitely has focus, as does the folder tree view itself. The folder tree is in edit mode. So it's like the key events aren't being processed properly. In the tree? This thing? There, maybe? Alright, well. There's our code coverage build. It's going to wait a little while. More TPS tests have been queued up. That's very nice. This places one sounds tricky. I think I need to know more about what this test does. Let's try running it and see what happens. I'll also bring up the source code. Hopefully it's somewhat readable. Kind of. First of all, it erases all of our bookmarks. Disables bookmark panel animation. Make the auto close timeout go away. Open a new tab at About Robots. And then we click the bookmark star, open the folder selector, click the new folder button, we create an observer, wait for the folder to be created, and for editing to start, wait for condition. And we create a rename observer, and then we synthesize the key F, and we return. For some reason, this key is not being accepted. All right, all our TPS tests are running now. So hopefully we'll have more data there soon. Okay, let's run this test. Monkey test. Nope. Let's see what it looks like. All right, here we go. Okay, so it likes that. Let's run it with the chaos mode stuff. Let's see what that does. We're stuck. I don't think this this test is designed to be run in verify mode. It's not designed to be run in like with repetition, unfortunately. All right. So the question is then, why didn't that key event get received by doesn't receive a change in the value of the field, hence when I approach the return there's no change. Doesn't determine focus correctly. The event. I guess that's the question, like what is focused? Another focus issue, so focused element. Focused element. Folder tree has attribute editing. Focused element, right? That's the thing. NSI focus manager. Make sure that is. Just to simplify things here, we're going to say l.tagname classes l.class set attribute or get attribute, and maybe even inner HTML. See what that looks like. Just give us a hint on like what it is that we're looking at. Focused element, HTML input classes, text input, inner HTML, nothing. Well, maybe that's enough. And let's see whether or not we can get this to rear its head. We see it on Linux 32, Linux 64 CCov, Windows 10 CCov. All right, well, let's do build type debug. Was the other, oh no, was the other one we were looking at here, the, is this for debug builds? No, it was not opt. Good. Okay, so let's see if we can get our build going here. So we want Linux 64 CCov, I think. Linux 64 debug CCov. No talos. Instead, we want to run Moki test BC. Trigger all test jobs 10 times. See if that works. Log the focused element in a test. All right, so lots of things cooking on try. Oh, we've got our TPS back. And lots of green. Everything's running green right now. On Mac OS. This is all green. So maybe let's retrigger a bunch. maybe this failure is gone. So I've re-triggered a bunch. Let's see if we can get this failure to appear. Then there's also the profiling variation. You might want to do that too. This I think is going to take a little while. The Linux 64 JSD cov. So we might not get any information out of that. All right, well, are there any other intermittent oranges we can look at before? Like, none of these have really been any slam dunks, because I need them to get a real slam dunk. You need to be able to like reproduce it locally. I want from all time failures, all time. Tree, Zilla Central. Well, this isn't very exciting. I was really hoping for a slam dunk, but we've only got like 15 minutes left. Say from the 1st of June to today. All right. Is there another one we can look at here? I'm trying to find something that I feel like I could be successful with, so I'm looking for like browser ones. Here's one. Test form autocomplete. Not a whole lot of work's been done investigating this just yet. Autocomplete pop-up not expected during test 253. This last failed. It was reported 3 days ago. I'm seeing a lot of it on like Win732 debug. On debug. Okay. And sometimes we get a screenshot whenever things go wrong, so we can take a look. That actually looks okay. Info pop-up shown for test 253. Autocomplete pop-up was not expected during test 253. And that was the failure. And if I remember correctly, this is one of those really like hard to read tests. Check menu entries. Wait for menu change. So I think autocomplete pop-up shown. Expect pop-up. So in the later tests, I think the pop-up's already supposed to be open, and that's why we don't expect for 253. Let's go back a little bit here. Look at form 6, try to trigger autocomplete pop-up. Expect the pop-up, send chart A. Look at the entries. Send another character, wait for the menu to change. That's what should be in the menu. Reset, focus, send char B. Menu entries should be that. Focus, send char space. And then focus, send char that. And somehow the pop-up's coming again. So I wonder if at some point the menu accidentally closed somehow. Because I don't know if check menu entries is checking to ensure that the menu is actually open. Get menu entries. Satchel. Parent util satchel comment. So get the last autocomplete results. Right. Register a pop-up shown listener. So I wonder if one solution here is to register a pop-up hidden listener and then try and notice when the pop-up may have hidden in a previous test, because maybe that's the problem. Not so much that the pop-up showed when we didn't expect it, but the pop-up was already supposed to be visible. It was already supposed to be up, but it went away for some reason. Pop-up hidden listener info. Pop-up hidden for test. Num. So let's register pop-up hidden listener. So it's like satchel common. Register pop-up hidden listener, a listener. I don't think this is something we super need to care about, but just for completeness, I'll add that for symmetry. All right, and then there's is there already like hidden? No. Promise HTC show pop show expected. Okay, here we go. G Chrome script add message listener on pop-up hidden. Nothing. I don't think there's an object there. G pop-up hidden listener. All right. Then parent utils. On pop-up shown. Send a sync message on pop-up hidden. No other information. And then do all this garbage. Pop-up. Hidden listener. Hidden listener. And then pop-up. Hidden. And I'm actually going to do something a little extra here. Pop-up hidden in parent process, and then I'm going to dump a stack. And then let's also clean up. And then I think that'll do it. So now if I run mock, Moki tests, toolkit, component satchel, test, what was it called? Test form autocomplete. That should do it. Then we should have our logging. Whoop. Pop-up hidden listener is not defined. And 227. Pop-up hidden listener is not defined. At register and satchel common. Oh. I think I have to, yeah, okay. That was the problem. Gotta declare my global variable, because those are great. I'm really just copying the pattern for the pop-up shown one. It's really not the best, but it allows me to get the job done. Woo, there you go. And then it's done. So, yeah, pop-up hidden in the parent process. That's exactly what we wanted. Okay, so now let's add some logging. Or, you know what I really should have done is put like commit, like the bug IDs of what I was working on. Here, I better put these in my notes so that I don't lose track and have to go through all this video footage. So that was for bookmarks, and then most recently I was working on there's one here, test autocomplete. Yeah, this one. And we're gonna run the Moki tests. As it excuse me, a special configuration. It's no special configuration. Tends to fail on Windows 32. So let's do that one. Run the Moki tests. Which Moki tests? Debug Moki test 5. So that's what I'll do. So not all of them. Moki test 5. Debug only. Win32. Retrigger all jobs 10 times. Whoops. Didn't mean to add that as my commit message for the actual logging. But I can work with that. Gonna push this and then I'm gonna end the stream. Unfortunately, I don't think we got any real useful information out today. Pushed a lot of stuff to try, but it was all just like hunting, and we didn't get much information. It's interesting that this all seems to pass correctly. This coverage stuff is running, so hopefully we'll have some information there soon. This coverage thing also running, and then this, I'm going to push it right now. Oh, not R try. Force try. And that's it. Hey everybody. Yeah, a little not a whole lot of actions took place where we solved real problems, but we created a bunch of try pushes that have a bunch of logging. That's a very realistic sort of approach to trying to figure out a bunch of these failures that only occur in automation. When you can't reproduce them locally, you have to just add a bunch of logging to try and figure out what's going on in automation. Sometimes we're lucky and we can reproduce the issue in automation and then log into that machine, like what's called a one-click loaner, log into that machine and then try and debug it there. But that's not always the case. That's actually quite tricky to do. What is ideal is when you're able to reproduce the test failures using like locally, your own machine. You can reproduce the test failures locally, and then you can use like the debugger or RR or local logging even, and then you can get answers a lot more quickly that way. Unfortunately, none of the intermittents we looked at seem to fall into that group, so we're relegated to pushing to try and logging a bunch, and that's what we did. Okay, so let's switch my screen. Well, hold on a second. Yeah, so that's it. Thanks so much for watching episode 144 of The Joy of Coding. Not bad. We'll see you next week. Next week, let's see, will be episode 145. We'll have, who knows what we'll be working on. It'll be an adventure, I promise. So have yourselves a great week. I will talk to you later. Take care. Bye-bye.
The joy of coding.
See ya.